community ground-based near real-time lightning warning system was installed within the community of Swayimane. This system composed of an electrical field meter. For example, this is a sample of the electric field meter which we utilized at the site. So basically, the electrical field meter is used to measure the electrical discharges that are present in the atmosphere, because as you would recall, before a lightning flash can actually take place, you have a buildup of electrical charges. And that was the purpose of this instrumentation, which was part of the system at Swayimane. Another component of the lightning warning system was a strike guard. And along with the strike guard, there was also a data logger that was present at the site. So what the system actually did was basically disseminate using audible and visible alarm systems. So the lightning warning system consisted of a siren and a beacon lights in that regard. And what was also quite unique about the system was that it could take it a step ahead and automate written notifications via SMSs as well as emails at nominated action or threat level. And in doing so, what this would do is that it would provide, for example, the rural communities, your farmers on the ground, as well as municipal officials and disaster management officials with some sort of a measurable threshold upon which then they could then react to on site.
Initially, when the project started, there was always a plan to measure the weather variables at the site. But once we had installed the weather station at the school, and we started understanding a bit more about the threats to the community, I'd been doing some work on lightning, and it just seemed to fit so well with exactly what the project was about. And that's sort of how the lightning warning system came about. The specific site at Swayimane High School was absolutely perfect for the measurement of lightning. It's located on this ridge with these valleys running down onto the sides. And a ridge is an area that is particularly prone to lightning and where you're most likely to get your ground strikes. So it made the value in installing the system very relevant, and particularly because you've got a high density of population, people at the school, where in terms of the number of people we're covering, there was good value for the investment in the URP project. So in terms of a warning system, this particular lightning warning system is really state of the art. With very good redundancy built in. This is the main sensor, the electric field meter, and it's got the brains or the data logger or the PLC inside this sensor, and it measures the buildup of charge in the atmosphere before a strike takes place. So in that sense of it, it really is an early warning system. The brains of the system are connected directly up to lights at the site. So if you don't have communication networks for some reason, if cell phone networks go down, you've got lights at the site with an audible siren that alert the people on site to the warning.
I'm Terry Tedder from the Richmond Fire Protection Association. We've been running the association since 2008. We've had camera detection in the Richmond area since 1994. So the early warning system just made absolute part of, or fitted into our program, our objectives very well. And we got involved with the program, and we managed to get funding for 2 cameras, one in the Richmond area, one in the Swayimane area. So basically we've got towers in the communities on top of high spots. Those towers are then, with technology and the software behind it, detect the fires, and it feeds back into an ops room. Then that ops room, the operators take control. Once the fire's been detected, they then decide on where the fire is, what risk there is, to who the risk is, and then dispatching people to go and sort it out, or notifying the landowner or the land occupiers of that there is a fire, there is an imminent risk. We are there to make a difference. We want to detect fires early. We want to get people on the ground. We want to help the communities where we can.
The main aim of the project was to develop a real-time and focusing early warning system for Umgeni District Municipality. And the anticipated outcome was then that the system will then be able to inform decision-making of the disaster management in terms of how to respond effectively in terms of flood management. So it will inform their flood mitigation planning. The three components of the real-time monitoring system includes the rainfall runoff model, which is where the flows are simulated or modeled. And the second part of the system is the MIC workbench, which is actually a decision support system with a database where then the rainfall runoff model is integrated to real-time information and the forecasted information. And then there's also MIC operations. It's part of the system which then presents the results or the outputs of the system, and you can actually view the actual outputs of the system in that component of the system. But the other component, which is also very important, was the flow gauges that had to be installed in the rivers, because in the pilot areas, we had to identify suitable sites in the rivers where we can be able to receive flow information that will also be feeding into the system. So we installed about 4 real-time gauges. There was one in Henley Dam. Henley Dam is upstream of the catchment, and the most important rainfall for flooding or flood monitoring is the rainfall that is happening in the upper catchment, because that rainfall will collect and then will be routed downstream. Obviously, the communities downstream will then be affected by that rainfall, which became a flow or stream flow or runoff, which will be passing through the communities downstream. So the communities that are downstream were the ones who were part of the communities that are within flood high-risk areas. So we had one gauge at Henley Dam, which will tell us how much flow is coming from the dam upstream. And then we had another one in Napierville prison at Msunduzi River. It's called Mason Mill. And we had another one in Slangspruit. Those are the 3 within the Msunduzi. It was very important for Umgeni District Municipality to have collaboration with Umgeni Water, because Umgeni Water, remember, we operate and maintain infrastructure that can either reduce the impact of floods or enhance the impact of floods, such as dams. So when rainfall happens and the dams are not full, the dams provide storage capacity. So before the flows go downstream to affect communities, it gets to be attenuated in those dams. Therefore, in that way, the dams are reducing the impact of floods. But when the dams are full and the rainfall takes place, it means then they will discharge flows, and those flows will be going downstream and affects the communities downstream. So it's important to then work with an organization that is operating and maintaining dams, because they have the information that can inform their decision making. Since we have the system and we're operating it, it means we also maintain it. So which was going to be maybe a challenge, because this project was a funded project which will run out of budgets, and therefore it means we won't be able to maintain the system. So Umgeni Water is already maintaining its system. So there is sustainability into the project.